I'm Bill Kinney, and this is the 7th video of my series on Foundations of Arithmetic, Algebra, and Graphing, with a focus on real-life interpretation and application. As I said, this is video 7, part 4 of a sub-series on multiplication of integers. And I usually do focus quite a bit on meaning and application, as I've been trying to emphasize, but in this video I'm going to focus more on a little bit more on pure math, algebra properties of multiplication and addition in this case, that are necessary if you want to get good at algebra and also get good at graphing and graphing lots of different kinds of functions in math. And I want to start by looking back at the a real-life example about thinking about your salary. This was the problem where you earn $9 per hour, work 8-hour shifts, and you work 5 shifts per week. And ultimately we wanted to know how much money do you make in a week, and our answer down here was $360 in 1 week, and I highlighted something called the Associative Property there. Right now I'm going to highlight a different property. You might recall that when I looked at this multiplication right here, I said that what I do in my head is that I first think of this as multiplying 70 times 5 to get 350, and then multiply 2 times 5 to get 10, and then the final answer is 350 plus 10. You might have wondered, why can I do that? How do you know that that's okay to do? And that's what I want to illustrate here. I'm going to illustrate it in a symbolic way, and we'll try to understand what I'm doing with smaller numbers here in a second. You can think of 72 as 70 plus 2. So therefore I can think of 72 times 5 as 70 plus 2, done first in parentheses, then times 5. I do need the parentheses here to emphasize that I want the addition done first before the multiplication, because if I don't have the parentheses there, then I just write 70 plus 2 times 5, and the precedence, the order of operations is that you would do the multiplication there first, but because of the parentheses, that emphasizes that I do the addition first in this case. And then I said again, you can think of this as 70 times 5, which is 350, plus 2 times 5. 350 plus 10 is 360. What I've just illustrated there is that I used something called the distributive property. Let's see if I can fit it here. I'm going to have to move things a little bit. Distributive property, which is another important algebra property. Essentially, the name comes from the fact that I can think of this 5 that's being multiplied out here as I'm allowed to distribute it through the parentheses into the 2 different spots there, times the 70 and times the 2. And that's what I did down here, 70 times 5 and 2 times 5. And then I add the results. So that's an example of the distributive property, very fundamental algebra property that you want to make sure you know if you want to be good at algebra. And you get 360. Maybe that makes intuitive sense to you, maybe it doesn't, but let's see if we can give a good reason for it based on thinking about smaller numbers and pictures. Well, let's say we want to think about, y is 2 times, let's do 4 times 3 plus 2. The distributive property would say that's the same as 4 times 3 plus 4 times 2. And by the way, here notice that I switched around the order of where I was multiplying from the previous one. I'm multiplying the 4 on the left here. I could have multiplied on the right. That's called the commutative property of multiplication, which we've already highlighted in a previous video. I'm putting the 4 on the left. It's okay to do that. Why do I get the same thing? Well, if you just calculate it here, remember the parentheses mean do what's inside the parentheses first. 3 plus 2 is 5. So this gives me 20. And then down here, 4 times 3 is 12, and 4 times 2 is 8. And notice those multiplications get done first. I don't have any parentheses here. I do not do 3 plus 4 first. There's not a 7 in there. I do the multiplications first, 4 times 3, 4 times 2. Those take precedence over the addition. Then I get 12 plus 8 is 20. I get the same thing. That might be reason enough for some people, but intuitively, why does that work? Well, you can think of it as a picture, if you like. 4 times 3 plus 2, which is really 5, can be thought of as you've got 4 rows of, say, 5 dots each. So each row here has 5 dots in it, and you've got 4 rows, giving you 20 dots altogether. If you just think about the picture in the following way, if you break it up into 2 pieces, this piece here and this piece here, in this piece you see you have 4 rows of 3 dots each. In this part here you have 4 rows of 2 dots each. That's the same as 4 times 3 and 4 times 2. Then you combine them, obviously, by addition to get the same 20 dots overall. So that is an illustration of the truth of the distributive property with this small case. That's essentially, that's the why of it. Let's spend just a couple minutes then reviewing the algebra properties that we've talked about here so far. One property was closure. That was a property of the integers overall. You add any 2 integers, whether they're positive or negative, 7 plus negative 11, you get another integer. There's the commutative property. And that works for addition or multiplication, as does closure, by the way. Though I haven't explained multiplying negative numbers yet. That's a subject for maybe the next video here. Closure of multiplication of positive integers, 7 times 3 is another integer. Commutative property works. Negative 11 plus 7 is still negative 4. 3 times 7 is still 21. Associative property is another one. You can do it for addition. Negative 11 plus 7 in parentheses plus 5 is negative 4 plus 5 is 1. And negative 11 plus, if I put the 7 and the 5 in parentheses, it's negative 11 plus 12. That's also 1. You can do it for multiplication as well. 2 times 3 times 5. If I put parentheses around the 2 times 3, I get 6 times 5, which is 30. But also 2 times 3 times 5 in parentheses is 2 times 15. That's also 30. And this distributive property that I've just mentioned, that I won't illustrate again for time's sake. I also mentioned additive identities and additive inverses. 0 is the additive identity. Anything plus 0 is that anything. Negative 5 is the additive inverse of positive 5, and vice versa. 1 is called the multiplicative identity. If I multiply anything times 1, I get that anything. And every non-zero number has a multiplicative inverse, but that involves fractions, which we haven't gotten to yet. These are all important for you. You might not think they are, but they are important. For example, they are important to know if you're going to use your calculator well, if you're going to use spreadsheets well, and we will eventually be getting to using calculators and spreadsheets in this video series. You need to know these properties well to use your technology well.